Hello guys, welcome back to the channel. Let's tackle another problem. Today's problem is also from bit manipulation. That's 2425 bitwise XOR of all pairings. Let's see what we are given. So we are given two zero-indexed arrays, nums1 and nums2, consisting of non-negative integers. There exists another array nums3 which contains the bitwise XOR of all pairings of integers between nums1 and nums2. Every integer in nums1 is paired with every integer in nums2 exactly once. So that returns nums3, right? Now we need to return the bitwise XOR of all integers in nums3. Let's set example 1. nums1 is equal to 2, 1, and 3, and nums2 is equal to 10, 2, 5, and 0. So what we are being asked, each element in nums1, we need to do XOR with each element of nums2. 2 XOR 10, that gives 8, 2 XOR 2, that gives 0, 2 XOR 5, that gives 7, 2 XOR 0, that gives 2, right? Same thing here. So basically, we are just doing the XOR of each element of nums1 and with each element of the nums2 that returns nums3, and we are doing each element of nums3 XOR with each other, right? Then that's returning one number. So let's the second example is similar. So we'll just look at that example later in the whiteboard. Let's say the constraints. So nums1, the length of nums1 array and nums2 array, it can range from 0 to 10 power 5. And each element, the value of each element of nums1 and nums2, it can range from 0 to 10 power 9. So just pay attention of this 10 power 5, the number of elements, right? Which means that if we are going to do this n square algorithm, that's going to be outside time limit exceeded, like more than 1 second, right? So 2 and with each element of nums1 with another each element of the nums2, it's going to be like n square algorithm, right? Then we need to do another iteration. That's going to be like very expensive. Let's see this in the whiteboard. Okay, so this is an example. So we are given this nums1, we are given this nums2. Basically, how we are forming this nums3, we are getting each element of the nums1, and we are doing the XOR of each element of nums2. So let's say 2 XOR 10, 2 XOR 10, it's giving 8. How it's giving 8? Because 10 is given in decimal. In the binary, it's going to be 1010, and 2 is 0 in the 4-bit, right? 2 is 0010. If we are going to do XOR, XOR is basically if 1 0 XOR that returns 1, and 1 1 XOR that returns 0, 0 0 that returns 0, and 0 1 XOR that returns not 0, but that returns 1, right? So here, if we just see 0 to 0, that returns 0s, 1, 1, again 0, according to this XOR. That's the property of XOR, right? And 0, 0, that returns 0, 1, 0, that returns 1. And this is in binary. In decimal, that's basically 8, right? That's why we are returning 8, right? And 2 to another 2, that returns 0, and 2, and all of them, right? That's how we are getting. And at the very end, we are being asked to do the XOR of 8 XOR 0 each element, right? Basically, I'm not going to type them. So I just simply put this XOR of 8 to 0 and 0 to 7, 7 to 2, all of them, right? Basically, and this returns one number. Then that output we are being asked, right? Same thing here. If the nums2 is this, nums3 is this, and we are basically doing the XOR 1 to 3 and 1 to 4 and 2 to 3, and 2 to 4, right? And this is how we are being returned. Then if we just do this 2 XOR 5 XOR 1 XOR 6, that is going to return 0, right? And this output is according, I mean, it's given in the problem definition, so that returns 1 output. Here it returns 0, right? So let's see some properties of this nums1 and nums2. Okay, so imagine the general case where we are given the nums1, a1, a2, a3, just some number of elements. I just chose this to be a odd number. And then nums2 is given b1 and b2. Just say imagine odd number or even number, it doesn't matter. Like let's just choose them differently to make this even, right? Now what we are being asked, basically a1, we need to do XOR of b1, right? And e1 to b2, right? e1 to b1, e1 to b2, e2 to b1 to each element, right? Each element of nums1 to each element of nums2, right? And b1 to b2, a3 to b1, this one, right? And a3 b1, a3 b2, right? And at the end, we need to do the XOR of each element, right? E1 to B1 XOR, E1 to B2 XOR, E2 to B1 XOR, all of the elements, right, of nums3 after we get this multiplication, right? So, and at the end, this will be returning the result, right? So this should be returning the result, and that's the result that we return. So XOR, it has the property as a commutative property. What it means is if A is XOR to B to XOR to C, we can change the place where A XOR to C XOR to B, or B XOR to C XOR to A, right? This is a commutative property. And also, there is another property. If A XORed with another A, okay, that's 0, right? Then this is even, right? If A XOR to A, this return this. If XOR to A, that's 0, right? Then if 0 is XOR to A, that returns A. This is odd. So if A is XOR to A and another A is XOR to another A, this returns 0, this returns 0. 0 XOR to 0, according to this property of XOR, that returns 0, right? So if you see the pattern, right? If you see the pattern, if a number is XORed by even number to itself, that's always 0. A XOR to A is 0. A XOR to A XOR to A, this is odd. This is A itself. If this is odd, if A XORed with each other 4 times, which is even, it's again 0. If we are doing this A XOR to A XOR to A XOR to A, another A, there's a 5. This will return A, right? So basically, we are going to use this property, right? So how we are going to use this? We are going to rewrite this property, right? Let's say this nums3. Nums3, as you can see, we have how many A's? A1, right? And A1, right? That's twice. And B2 is also A2 to A2 is also twice, right? So each element of this nums1 array is multiplied to each element of nums2, right? If we are going to rewrite this one using this property, commutative property, that will basically return, we are going to collect, we are going to collect all of the A's together, right? All of the A1s together. A1 to A1, right? Then we just collect this, then B1 B2, right? No, let's collect all of them together. How many A1? A1 to A1 and B1, B1, B1. B1 is basically XORed with each other three times, right? Then this is also XOR. Then A2, let's say A2, how many times? 1 and 2. A2 XOR to A2. Then what about B1 and the B2? B2 is 1, 2, and 3. B2 is XOR with each other to how many times? B2 XOR B2 XOR B2, right? So that's also XOR three times, right? I'm just simply just rewriting this multiplication, right? This array after XORing. I'm collecting all of them so that I can use the commutative property of the XOR. So this one, if A1 to XOR to A1, what's that? It's 0, right? It's an odd even time. That's 0. What about this one? This is basically B1 to B1 to B1, right? So let me just clean up some space here, right? So yeah, sorry guys, it's a little messy here. So B1 to B1 to B1, this is 0, this is a B1, this again even times, that's 0 again, right? And this one is B2, right? If you just see what you see, if this A1, how many times it's appearing? It's appearing whatever the length of the nums2, right? Nums2 is 2, so that's why it's A1, each element of nums1 appearing the number of times the length of the nums2, right? If the nums2 is the length is 2, this A1 is because it needs to be multiplied to each element of the nums2. That's why this A1 is appearing twice. What about the B1? B1 will be multiplied to each element of the nums2. That's why it's appearing. It's the length is 3. That's appearing this 3 times, right? And A2 is also, it appears the length times of the nums2, right? There's a nums2 is twice, length is 2, so that's why it's appearing twice. And B2 is the same. B2 will be multiplied to each element, so it should be appearing 3 times, right? So what this basically tells, so if the length of nums2 or nums1, if it's odd, so each element will appear by itself, right? Like this. If the length of the one of this is even, so then each element will be XORed by itself the number of times of the length 2, right? So then this will be 0, B1, and 0, and B2. At the very end, so we will be looking at this. What is this? 0 multiply XOR B1, XOR 0, XOR B2, right? So B1 and B2. At the end of the day, we'll be just XORing B1 to B2, right? Basically. And it will be XOR to 0 to, right? 0 to 0, so XOR to 0. So that will be returning the 0. So here, what we can do, right? So the nums1 length is 3, nums2 length is 2, right? So we can basically, each element of this will be XORed by itself the number of times the length another array, right? So 1, 1, 2, 2, 3, 3, and this one will be XORed by itself, and this is 0, 0, 0, right? And this one will be 4 XORed to 5, right? And it will be XORed to 0, right? And this will be returning the output or the result, right? Basically, all we need to do, we need to compute the length of each array, and if it's odd, then we keep it, right? If it's even, then the elements will be 0. Initially, XOR will be 0, then we just compute what's the XOR after that, right? Let's look at the code. So here we are going to do the lengths 1 and length 2 of each array, right? Then we need to calculate the XOR of elements in number array 1, right? Initially the XOR of array 1, it will be 0. Then if the length of array 2 is odd, then that's when we can do the XOR of all the elements of the array 1, right? Then the initial XOR 0, so basically we'll be just XORing each element of array 1. The same thing we do here, XOR result 2, we initialize to be 0. Then it depends on the XOR of the second array will depend on the length of the first array, right? Because each element of the nums2 array, it will be multiplied with itself, right? By the length times of the first array, right? So if if this is odd, then we can compute the XOR of each element of the array 2. At the very end, all we need to do, we need to return XOR of the first array and XOR of the second array. If this is if the length is odd of each array, then this will be returning the result, right? If it's if one of them is even, then XOR will be 0, right? Then we just basically simply return the XOR of each that's XOR result 1 and XOR to XOR result 2. So the space and time complexity, the time complexity is O of m plus n. M is the length of the first array, n is the length of the second array, and space complexity is O of 1 because we are not keeping any, we're not storing anything in an array, right? So basically that's it for this problem, and I hope you guys it was clear, the solution in the whiteboard and the code walkthrough. If you have any comments, and please share your comments below in the video. And if you are liking this video, please share with anyone that you think might be helpful. Okay, thank you. See you in the next video. Bye.